Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 46, permutations. So for this problem, we're given an array called nums, which is made up of distinct integers. We have to return all the possible permutations, and we can return the permutations in any order. Okay, let's suppose we're given this integer array nums with the elements 1, 2, and 3. We then have three options for the first element in a permutation. And a permutation is just a reordering of the numbers just so that we have the same length in each of the permutations. So for the first option, we can either take a 1, we can take a 2, or a 3, and we can kind of make a tree representing the different options. So here we can have just the 1 element, we can have a 2 element, and then a 3 element. And then from the 1 option, we can either take a 2 or we can take a 3, since these are the remaining elements in the nums array. We can't use the same number multiple times, otherwise it would not be a permutation. So we can either take a 2 or a 3, so we have two options here. We can have 1, 2, or we can have 1, 3. And the same thing for the 2 option and the 3 option. We can have 2, 1, or we can have 2, 3. We can't have 2, 2 because we already used the 2 element. And then for the 3 option or the 3 path, we can have 3, 1, or we can have 3, 2. So these are all the 2 element permutations, you could say. So we need 3 elements in a permutation. So we can continue on with the last option. And for each of these options, we only have 1 element remaining. So we can only have 1, 2, 3. We can have 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and finally we have 3, 2, 1. And you can see that we have 6 permutations, and these are all the permutations for the given integer array nums. Well, from this tree, I think it's pretty simple on the intuition. So what we did was we took each element in the nums array. So let's say we start with 1, and then we go down and select this path, and we construct what is known as, let's just say, a path, right? And the path is going to contain basically the array before it reaches the length of the original integer array, which was 3. So as long as we're not at a length of 3, we know we can keep going with the other elements. So now we can store this in some set to tell us that we've already visited 1, and so that we don't visit it again. So we can store this in some visited set. And then what we can do is we can basically recursively call this function to add the remaining elements. So here we can call again, and we add 2 because we already see that 1 was in the visited set. So now that means we have 1, 2 as the path, and then we can see that the length of this entire array is 2 at this point, which is not 3. And this kind of indicates to us that 3, or the length of the integer array, is going to be the base case of this recursive function. So we can keep going or recursing down. So here we know that the visited set is going to be consisting of 1 and 2. So 3 is the only option in the nums array that's not in the visited set, so we add it. But then we check and see that we have reached the length of the integer array, and that means we can return. We can't continue going down because we've already exhausted all the elements in the integer array. So now that we've completed basically this entire path, we basically add all the found paths, so this one and this one, into some resulting array so we can keep track of all the permutations. Then what we can do is we can do the same thing with 2 and 3. And this will work because we're just looping through each of the elements one by one and adding them to a visited set. So with that being said, we can go ahead and write the code approach on LeetCode. Okay, we're on LeetCode and we can begin writing the solution. So we can begin by initializing a result array, and this is going to have all the permutations at the end. So we can just return result at the end. So this is what we're going to do. We can also keep a visited set, and this is going to keep track of all of the elements that we've currently used in a singular path. Then what we do is we can establish or declare a DFS function. So we can say define DFS, and it's going to take the path. The path is going to be some array that we're appending elements onto, because the return is going to be a list of arrays. So we know that our base case is going to be when the path is equal to the length of nums. So we can just say if the length of path, if it's equal to the length of nums, then we want to append it into the result. But we have to be careful because we're going to be mutating this path. And since it's a list, we have to do a deep copy. So path.copy, just so it doesn't alias, and then we can just return out of this since it's the base case. Then we can loop through each of the elements. So for num in nums, and if it's not in the visited set, so that means we haven't used it yet. If num not in visited, then we can do our backtracking. So visited.add num. So we add it into the visited set. We also want to add it or append it to the path. So this is going to be what we're appending at the end to the result array. And then we call DFS again until we reach this base case. But once we reach this base case, we're going to want to remove this element from the path and the visited set. So we can do visited.remove num, and we can do path.pop. So these are both in O of 1 time, since adding or removing to a set is O of 1, and path.pop is also big O of 1. It's just the end of the array. Finally, we can just call the DFS function, and we'll call it with the empty path since there are no permutations currently. So once we call this, it will populate the result array, and then we can return the result array at the end. So we can try and submit this. And you can see that the code is accepted and it runs decently fast. This is equivalent to the optimal solution. We can kind of avoid using the visited set, but it makes it much more clear in my opinion. So with that being said, hopefully this video helped you. and you learned something, and I'll see you soon.